Good day. In this tutorial, we're going to solve a problem pertaining to analysis of variance, design and analysis of single factor experiments. In this example, a manufacturer is interested in improving tensile strength of a product. Hardwood concentration from 5% to 20% is the factors that management thinks that has an impact to tensile strength at 4 levels. So this is an example of a completely randomized single factor experiment with 4 levels: 5%, 10%, 15%, and 20% of the factor. We're going to find using ANOVA, or analysis of variance, in investigating 24 random experiments at alpha 0.01 with their different hardwood concentrations do not affect mean tensile strength of the paper or the product. Take note that small a is the number of groups. We have 4 groups: y sub 1, y sub 2, y sub 3, y sub 4, assigned to the hardwood concentration percentages: 5, 10, 15, and 20. We also have the number of observations. We have 6, which is small n, and the number of samples is 24, represented by capital N. You have noticed that I have arranged this table by way of hardwood concentration, represented by y sub 1 in column, y sub 2, y sub 3, and y sub 4. First step is to create additional columns: y sub 1 squared, y sub 2 squared, y sub 3 squared, and y sub 4 squared. We just fill this up. For example, for y sub 1 squared, in this first row, 7 raised to 2 is 49, and we will do that to the rest of the rows. For y sub 2 squared, it is 12 raised to 2 equals to 144, and we will do this to the rest of the rows. For y sub 3 squared, it is 14 raised to 2, 196. And for the last column, y sub 4 squared, it is 19 squared equals to 361. And we will do this to the rest of the rows. Now we will get the total for each columns, and then we will get the square of y sub I, which is the total. For example, 60 raised to 2 is 36, 94 raised to 2 is 8,836. For y sub 3, 102 raised to 2 is 10,404, and 127 raised to 2 is 16,129. Now we get the grand total for y sub 1 up to y sub 4. We have 60 plus 94 plus 102 plus 127 will give us 383. The grand total for the new columns: 640 plus 1512 plus 1750 plus 2723 will give us 6,625. Then the grand total for this, we have 36 plus 8836 plus 10,404 plus 16,129 will give us 38,969. Now we can compute for the total sum of square, or SST. We have 6,625 minus this one, 383, and then we square it, divided by, we have the big N, which is 24, we compute this and we will get 512.96. Next, we will compute for the sum of square of treatments. This one, 38,969 over the number of observations. Small n is 6 minus 383 squared divided by the big N, which is 24, number of samples. We will compute this and we will get 382.79. Next, we will compute for the sum of square of errors. We will put SST here, 512.96, minus the SS treatments, 382.79, and we will get SSE as 130.17. Now we can solve for mean square of errors, MSE. We have SSE 130.17, this one, divided by 4, which is the small letter A, which is the number of levels, multiplied by 6, which is the small letter N, minus 1. This will give us 6.51. Next, we will compute for the mean square of treatments, that is SS treatments, 382.79 divided by small a, which is 4, minus 1. This will give us 127.6. Now, we will create the analysis of variance table using these formulas. We can see that the values are similar from what we get a while ago. And then in this portion, we will get the F stat, which is the MS treatments divided by MS error, will give us 19.6. And from here, we will conduct hypothesis testing. Our null hypothesis is that there is no difference among the treatments. And then the alternative hypothesis is that there's a significant difference among the groups or the treatments. Our given alpha is 0.01, and we will test using these conditions. F stat is 19.60. For a minus 1, it is 3. And in this one, a multiplied by n minus 1 is this one, 20. And in our F table, this is V sub 1 and this is V sub 2. Our F distribution table, critical values of F at 1% significance level or 0.01 alpha. For V sub 1 is 3. We will look here. And then V sub 2 is 20. We will go down up to 20, which is here. The value is 4.94. So we have 19.60 greater than the value for this is 4.94 at the F distribution table. If it is true, we will reject the null hypothesis. Since this is true, we will reject the null hypothesis. Therefore, there is at least one difference between the groups or treatments. It means that hardwood concentration affects mean strength. However, it does not say which group or treatment means are different. So we can use the Fisher's LSD method to isolate the specific difference. Hope you have learned from this lesson, and I will see you on my next video. Keep safe always, and God bless.